Welcome you all. I am Shreenath, Faculty of Mechanical Department, Canara Engineering College, Mangaluru. On this today's session, I will explain about the introduction and types of fluid flow. Actually, this topic comes under in module number 2. The topic title name is Fluid Kinematics. Fluid kinematics is defined as that branch of science which deals with motion of particles without considering the forces causing the motion. In fluid mechanics, so here the characteristics of the properties are evaluated when it is in motion. There are two methods, either it is maybe fluid kinematics or fluid dynamics. So in fluid kinematics, the fluid is in motion and its characteristics are evaluated but without considering any forces causing the motion. So any type of the forces are not taken into consideration, then properties are studied in this fluid motion, that is called as fluid kinematics. The velocity at any point in a fluid flow at any time is studied in this branch of fluid mechanics. So here the velocity of the fluid is studied and the time is taken into consideration. So if you know once you know the velocity of the fluid, so then pressure distribution as well as forces acting on the fluids can be determined. Next up, methods of describing fluid motion. The fluid motion is described by two methods. The first method is called as Lagrangian method. Second one is Eulerian method. So these are the two important methods to evaluate or to study about the fluid motion, that is a Lagrangian method as well as a Eulerian method. So in Lagrangian method, a single particle is followed during its motion and its velocity, acceleration, density, etc. are described. But in case of Eulerian method, the velocity, acceleration, pressure, density, etc. are described at a point or section in a fluid flow field. So this is a diagram that shows there is a chimney and exhaust gases are leaving through that chimney. So now in order to study about the Eulerian method, so now attach a temperature measuring device to the top of the chimney and record the temperature at that point as a function of time. So in this one there is a chimney and exhaust gases are leaving through this chimney. So now one temperature sensing or temperature measuring device is connected at the point or the location O, and that temperature recording device measures the temperature of the particles flowing through that section. So actually here the temperature shows the temperature, the function of x naught, y naught, and that means in case the two or more number of temperature sensing instruments are connected at the different locations, at that time it measures the temperature at the different locations, and also it studies the temperature at a different time. But here the fluid particles are different. There is a continuous flow of the exhaust gases through this location. That means now this temperature sensing unit measures the temperature with respect to time. So at different times there are different fluid particles are passing by the stationary device. So here the temperature measuring device is stationary and different fluid particles are coming in contact with this fluid flow. So thus one would obtain the temperature T for that location and as function of time. So this is one location. If you assume this is a x0 position, and x0 position we will get the temperature at different time as a function of what? Time. So in case of Lagrangian method, the one would attach the temperature measuring device to a particular fluid particle. See this one. There is the flow of exhaust gases through this chimney. So one temperature measuring device is connected or attached to a particular fluid particle. So now you are measuring the temperature of that fluid particle at a different time limit. That means here you are getting the temperature of the particle A. So this is a particle A. The temperature of particle A. So here you are measuring the temperature of the particle A at the different time. That means once again this is a function of what? Time here. So here the temperature measuring device to a particular fluid particle and record that particle's temperature as it moves about. Thus one would obtain that particle's temperature as a function of time. So in this Lagrangian methods we are getting the temperature of that particular defined fluid particles at the different time. But in case of Eulerian method, the fluid particles are different because that measuring device is fixed at one location and exhaust gases are flowing continuously through that section. So that means that temperature measuring units measure the temperature of the fluid, different fluid particles. The use of many such measuring devices moving with various fluid particles would provide the temperature of these fluid particles as a function of time. So this figure there shows once again related to the Eulerian method as well as Lagrangian method. So in case of Eulerian method, so here it shows what Mr. Euler is at one particular location, and in particular locations the fluid is flowing through this one, or object is flowing through this section, and different fluid particles are coming in contact with this section, and that measures the characteristics of the fluid. But in case of Eulerian Lagrangian method, so here the measuring device that is connected to that particular fluid particles, and that measures the characteristics of that fluid particles at the different time. Once again this figure, the first figure, this figure there shows what Lagrangian method. That means the observer is connected, or observer is connected to one particular missile. But in case of Eulerian method, the observer is here, a fixed point. The observer is at one fixed location and the missiles are passing through that objects. The Eulerian method, the pressure, density, velocity is a space. There is a function of both space as well as time. But Lagrangian method is only function of time. So what are the different types of fluid flow? The fluid flow are classified as, the first one is steady and unsteady flows. Second one, uniform and non-uniform flows. Third one, laminar and turbulent flows. Fourth one, compressible and incompressible flows. Fifth one, rotational and irrotational flows. And last one, 1, 2 and 3 dimensional flows. So these are the various types of fluid flow. So now we will study about these types of fluid flow in detail. The first one, steady flow and unsteady flows. The steady flow is defined as that type of flow in which fluid characteristics like velocity, pressure, density, etc. at a point do not change with time. Thus, for steady flow, mathematically we have the change in velocity with respect to time is equals to 0. So here in a steady flow at a particular position at particular point there is no change in fluid characteristics. That means the velocity, pressure, density, etc. are remains same with respect to time. So in first case, in case of steady flow, there is a change in velocity with respect to time is equals to 0. And here x0, y0, z0 is a fixed point in the fluid field. Then dou p by dou t, there is a change in pressure with respect to time is equals to 0, and change in density with respect to time is equals to 0. There is no variation in fluid characteristics at one particular position with a function of time. So that is called as steady flow. So in case there is a change in velocity, there is a change in velocity or change in pressure with respect to time at a particular point is called as unsteady flows. So these are the expressions connected to their steady flow as well as unsteady flows. Then second one is uniform and non-uniform flows. Uniform flow is defined as that type of flow in which the velocity at any given time does not change with respect to space. The space means there is a length of direction of flow. The mathematically for uniform flow, the change in velocity with respect to space is equals to 0. So that is a constant. There is no change in velocity with respect to space coordinates is called as uniform flow, and the time is constant. So here dou v, that is equals to change of velocity, dou s is the length of flow in the direction of s. So dou v by dou s, the time is constant, that is not equals to 0. If you find there is a change in variation in velocity with respect to space coordinates, so then it is called as uniform, non-uniform flows. If you find there is a change in velocity with respect to space coordinates, that is called as non-uniform flows. Then laminar and turbulent flows. Laminar flow is type of flow in which fluid particles move along a well-defined paths or streamline, and all the streamlines are straight and parallel. So here fluid particles are moving at parallel to each other. For example, there is a pipe. So now fluid particle A is here, that is, it takes the path like that. Then fluid particle B is here, that takes the path here like that. Then fluid particle C is here, that takes the path like that. So that means these fluid particles are following one streamlines, or it is moving parallel to each other. So there is no mixing of these particles between in between these particles. That means there is a that means these fluid particles are moving at the one predetermined path. So that is called as laminar flow. So then turbulent flow, the particles move in laminars or layers here next, related to laminar flow, the fluid particles move laminars or layers, gliding smoothly over the adjacent layer. The type of flow is called as a streamline flow or viscous flow. So once again, this laminar flow is also called as streamline flow or viscous flow, because these fluid particles are moving parallel to each other. So coming to the turbulent flow is type of flow in which fluid particles move in zigzag way. So here there is a pipe, and then fluids are flowing through this pipe. Now the particle A, so that takes a path like that, and fluid particle B, that takes the path in this manner, and one more particle, the fluid particle, there is a 3, once again that will move in this manner. So that means here we can see what the fluid particles are moving in zigzag way. So such fluid particles or flow is known as turbulent flow. So due to movement of particles in zigzag way, the eddies formation takes place. So that means that type of flow is also called as some swirling actions are taking place on that fluid flow, so which are responsible for energy loss. So these are the difference between this laminar flow and turbulent flow. Then how do you categorize whether the flow is a laminar flow or turbulent flow? So actually this one is categorized based on the Reynolds number. So Reynolds number is a one dimensionless number. So here for a pipe flow, the type of flow is determined by the non-dimensional number, that is Vd by V nu, the called as Reynolds number. So where D is the diameter of pipe, V is mean velocity of flow in pipe, then nu is equals to kinematic viscosity of the fluid. So actually this one is also obtained one more expression. Reynolds number is given by Re is equals to rho Vd by mu, that is a dynamic viscosity. So Reynolds number is given by rho Vd by mu, that is dynamic viscosity. So we know that the mu by rho, the mu by rho is equals to kinematic viscosity, but here it is what, the rho by mu. So that is a reciprocal, for that reason it is taken as 1 by, because of this one is taken as 1 by nu, 1 by kinematic viscosity, and the numerator, the Vd is here, the Vd, the same expressions are shown over here, that is Vd by nu. So that is called as the Reynolds number. So in case by finding the value of this Reynolds number in a pipe flow, if the Reynolds number is less than 200, in case after substituting the values of this rho Vd and mu or Vd by nu, so we will, in case we get the answer or the value of 2000, the flow is called as laminar flow. Laminar flow, or the fluid layers are moving in parallel directions. If the Reynolds number is more than 4000, the flow is called as turbulent. So this is a method of analyzing the whether it is a turbulent flow or laminar flow in a pipe flow. What that means, fluid is flowing through a pipe. So next one is compressible and incompressible flow. So compressible flow is that type of flow in which density of fluid changes from point to point, or in other words, density of the fluid is not constant. So when fluid is flowing through a pipe or a channel, if its density changes from the point to point, if the density is changes from point to point, so that is called as compressible flow. That means the density is not constant in a fluid. But incompressible flow, mathematically for compressible flow, density is not constant. The density is not constant, it is called as compressible flow. Incompressible flow is that type of flow in which density is constant for the fluid flow. The density remains constant throughout its flow. Liquids are generally incompressible. The liquids, if you take any type of fluid or liquids, so that is incompressible, while gases are compressible. Gases are compressible. The incompressible means the density remains constant. So these are the examples for the incompressible flow as well as compressible flow. Next one, rotational and irrotational flows. Rotational flow is that type of flow in which fluid particles, while flowing through streamlines, also rotate about its own axis. So for example, the fluid is flowing through this pipe now here. The path followed by the fluid, the example, take one fluid particle here. So now path followed by the fluid particle is like that. This is the fluid particle. The initially fluid particle is here. After certain time it occupies a path here, and then it occupies a path here. Then it occupies, after certain time it occupies a path here. So that shows what? Now it is moving in what? Streamline. So along with that movement, along with that streamlines, this fluid particle will also rotate with its own axis, either in clockwise direction or in anti-clockwise direction. So the fluid is taking the rotation on this whole axis. So that type of fluid flow is called as rotational fluid flow. The rotational fluid flow is that type of flow in which fluid particles, while flowing through a streamline, also rotate about their own axis. The irrotational flow, if the fluid particles while flowing through streamline do not rotate, that means it is flowing through in streamlines only, but there is no rotation of the fluid particles. In that one, it's called as irrotational flow. Next, 1, 2 and 3 dimensional flows. One dimensional flow is that type of flow in which the flow parameter such as velocity is a function of time and space coordinates only. Say x, there is only one space coordinates, that is x. So now here for steady one dimensional flow, the velocity is a function of one space coordinate only. Mathematically, one dimensional flow is given by, so here u is equals to function of x, the v is equals to 0, so w is equals to 0, where u, v and w are velocity components in x, y and z directions. That means in one dimensional flow, the velocity is a function of only x directions. There is only in a x direction, other two direction it is taken as 0. In case of two-dimensional flow is that type of flow in which the velocity is a function of time and two rectangular space coordinates, say x and y. That means mathematically expression for that two-dimensional flow is the u, there is a velocity in the direction of x, and v is a velocity in the direction of y. So now it is in which the velocity is a function of a time as well as the two rectangular space coordinates, that is x and y. For that reason, the u is a function of x and y, as well as in the direction of y the velocity is equals to v, so that is a function of x and y, but in third coordinate that is equals to 0. Three-dimensional flow, the velocity is a function of time and three mutually perpendicular directions. The expression becomes for that one, u is a function of x, y and z, as well as in y direction that is a function of x, y, z, and also in third coordinate that is function of x, y and z directions. In this session we studied about, so what is fluid kinematics, so what are the methods of describing the fluid, kinematics. Then we discussed about what are the different types of fluid flow. Thank you all.